Use the factor theorem to show that x minus 1 and x minus 4 are factors of x cubed minus 21x plus 20. Show that x minus 1 and x minus 4 are also factors of x cubed minus 10x squared plus 29x minus 20. Hence, fully simplify this rational polynomial function. Okay, so here's the question in summary form then. So, factor theorem for part A. Let's let that equal f of x. And then we can just write f of the value, f of 1 then, by the factor theorem. It should equal 0, so let's have a look. It's 1 cubed. Minus 21 times 1 plus 20. Minus 21, that's 1 minus 21 plus 20, which equals 0. And also f of 4 now. This time it's going to equal 4 cubed minus 21 times 4 plus 20, 64, minus 84 plus 20. 64 and 20 is 84, take 84 is 0. So we've shown that, part B. Show that x minus 1 and x minus 4 are also factors of this. Well, x cubed minus 10x squared then, plus 29x minus 20. So let this equal, okay, so x minus 1, x minus 4 times ax plus b. Let's suppose that's the case, and we'll see if we can work out a and b. So x cubes, let's have a look at that. There's 1 on this side, equate coefficients, and then here we'll just get an a, because the x cubed is here, so a is 1. Now the constant terms, I'll put x equals 0 in, we get minus 20, and here we get 4b, and that tells us that b will equal minus 5. Divide by 4, minus 5. So a is 1 and b is minus 5. So let's just check that then. Oh, let's just check it with the x squared, because we want to make sure they are identical. So because it just said the question was phrased in such a way that show that this are also factors of this. So what I'm going to do here is I need to equate, well, we could do f of 1, couldn't we? Or let's just do x squareds then. Let's run through the whole thing. There's minus 10 here, and here we got an x squared from here, and that would times by the b, so that would be equal to b. And then the other x squared would come from just the x terms, wouldn't it, in this bracket? So minus 4 minus 1 is minus 5x, times the ax is minus 5a. Now b minus 5a is minus 5, minus 5 times 1 is minus another 5, which is minus 10. So that's fine. And the only other thing we need to check is the x terms now. On this side we've got 29. And on this side, the x terms, well, you'd have minus 5x here times b is minus 5. And then the 4, the number, times a plus 4a. So that's equal to minus 5 then. A is 1 plus 4 is minus 1. So I'm a bit worried about that. The x term here is 29. Let's have a look again. Minus 4x minus x is minus 5x times b. b, there we are, is minus 5. So let's put that in. That's where the glitch was, the error. So it's times another minus 5 plus 4, which is minus 25, plus 25. Minus times minus plus 4 is plus 29. There we go. And there's the that's fine as well. So a bit long-winded, that one. We could have used the factor theorem in the second part, couldn't we? In part B, to show these two were factors, but now by doing this, we've actually got what that cubic equals. Okay, so now part C then, hence simplify. So part C, so here. Now the only thing we need to do is just do the top part. X cubed minus 21x. And it's plus 20, isn't it? Plus 20 is equal to x minus 1, x minus 4. And then we need another ax plus b, don't we? Let's use capitals. So let's equate the x cubed. So we know these are factors, so we can just write this down now. So we'll get a is equal to 1 with the x cubed. That tells us that capital A is 1 then. 1x cubed on this side, and the x cubed is a on that side. The constants, on this side it's 20. On this side it's only going to be the b times the 4. So b equals 5. So let's call this in the question g of x. So here then, here g of x is equal to x minus 1, x minus 4, times x plus 5, ax plus b, divided by the x minus 1, x minus 4, and the other one above was x minus 5. So the answer is x plus 5 then, over x minus 5, because these two things cancel each other out when we simplify it.